All right, guys, we're going to take a look at geometry proofs. We haven't done any of these yet, and really the best way to learn them is just to keep working through them. I know it's not super easy, so you're going to have to hang in there. Don't give up and quit just because they don't make sense at first. They don't make sense for anybody. So when things get tough, you keep pushing through. You don't quit. You keep asking questions. You keep working hard. As long as you keep doing that, you're going to keep getting better. That's all that I ask. But you keep getting better. You keep improving on how you've been doing. So the basic premise of a proof is that you're going to have statements and reasons. Your statements are like claims that you're making. You're saying that these are facts. Your reasons are how you know the claims that you're making. It's called a two-column proof. So guess what? We're going to draw two columns. The first column, those are your statements. Those are your claims. The second column are your reasons. And so we have to be able to back up everything we're saying. We have to prove step by step every little detail. We can't skip anything. It's kind of like if you were a lawyer and you had to present a case to a jury. You have a wide range of people on a jury. You have extremely intelligent, quick-witted people. You have people that might take a little longer to understand things. And you got to make sure that nobody misses anything if you want to miss that case. So you can't just assume that they're going to connect all the dots. You've got to individually connect every dot piece by piece carefully to make sure that everyone's with you. And that's kind of what we're doing here. We have to use the information that we're given. There'll be a given statement most of the time. And then the picture goes with it as well. And we have to explain what we know from the given statement. We have to explain what we know from the picture that we see. And then we have to tie those ideas together and hopefully eventually be able to prove what they're asking us to prove. So it's kind of hard to explain. Let's just work through it some and see if we can figure it out. The first thing that they told us is that lines that appear parallel are parallel. So our first statement is always going to just be exactly what they told us. Lines that appear parallel, and I'm going to use the parallel symbol, are parallel. How did we know that? So that's our claim. How do we back that up? Well, that was just given to us. We don't have to prove things that we are told are true. We can assume that these things have already been established. We do not have to go out of our way to prove that. So that's the given information, and we need to use that. Well, there's nothing really there to explain, but I do like to make notes in the picture. So if lines that look parallel are parallel, that means that these two red lines are going to be parallel. Those look parallel, so they're parallel. And these two blue lines are also parallel. So if they look parallel, they are parallel. That's good news, because if you recall, we only have properties in between parallel lines. So because the blue lines are parallel, we can move left and right, right? The left and the right are my two blue lines. So we could do things like angle 3 and 2 have to add up to 180. Angle 1 and 2 have to be congruent. Angle 1 and 4 have to be congruent. We know all of those facts because the blue lines are parallel. We also know down here, we know that 5 and 7 are equal because of the parallel lines. We know that 6 and 7 have to add up to 180. This is the kind of stuff we're going to have to use to eventually prove 1 and 7 add up to 180. So here's angle 1 and here's angle 7. There's no direct link to them, between them. Angle 1 is made with these two lines. If I erase angle 7 off the face of the universe, it's just gone. Did that have any impact on angle 1 at all? No. Angle 1 and 7 have nothing to do with each other. So we're going to have to find some other way to link them because there is no direct link there between the two. So we got to use our parallel lines. Look at what we're trying to do. We're trying to prove that 1 and 7 add up to 180. So we want to somehow connect or link 1 to 7. And there's more than one way to do it. But what I'm going to do is I'm going to start at 1, and I am going to connect it to angle 6. Right? We know that the red lines are parallel. So what kind of angles are they? Well, there's a few ways you can tell. So this is the transversal. They're on the same side of the transversal, and one's inside and one's outside. What do we call that if they're on the same side, one in, one out? Those are called corresponding angles. Another thing, if you were to trace this situation, if you were to trace angle 1 and 6, they make the letter F. And if you recall, when you make the letter F, the inside corners of the letter F, those are called corresponding angles. And we have 5 statements. Let me go over those again real quick. There are 5 things we know. If lines are parallel, there are 5 things that we know are true. We know that corresponding angles, alternate interior angles, and alternate exterior angles, we know that all of those will end up being equal. If lines are parallel, we also know that same side interior and same side exterior angles, that those will end up being supplementary. So parallel lines, we have 5 rules as a result of having parallel lines. One of them being that corresponding angles are congruent. So we are going to say that angle 1 is congruent to angle 6. And that is the corresponding angle theorem. You can put T there for theorem if you want, but it's the corresponding angle theorem. And what does the corresponding angle theorem state? It states if the lines are parallel, then the corresponding angles are equal. So the lines have to be parallel. Just being corresponding is not good enough. It's the parallel lines that make them congruent. But it's called the corresponding angle theorem. You can put the T there if you want. Okay, so 1 and 6 are congruent. We know that. Actually, and because they're using measures, I'm going to use measures. This is not a big deal. I am not going to grade that real hard, but I'm going to stick with measures. The measure of angle 1 is equal to the measure of angle 6. Not a big deal, but shapes can be equal. Sorry, numbers can be equal. Numbers can be approximate. So those are for numbers or quantities. Shapes can be congruent and shapes can be similar. Those are for shapes. If you mess it up, I'm not going to take off any points, not a big deal. But numbers are equal, numbers are approximate, shapes are congruent, shapes are similar. All right, so we know that angle 1 and 6 are equal, corresponding angle theorem. Well, so we have 1 connected to 6. Can we connect 6 to 7? Well, they use the 2 blue lines. What kind of angles are they? Well, they're on the same side. Are they in the space between? Nope, they are same side exterior. You can watch the other videos if you're not real strong with that. I'm not going to take a lot of time to explain that here. But what has to happen? If they're same side exterior angles, then the measure of angle 6 plus the measure of angle 7 must be 180. And that is the same side exterior angle theorem, right? It's the parallel lines that cause same side exterior angles to be supplementary. That's what the theorem states. Okay, well, that's as far as we can go there. Now, what's going on here? 1 and 6 are the same size. 1 and 6 are equal. In math, if 2 things are equal, then they're interchangeable. That means anywhere I see angle 1, I can replace it with angle 6. Anywhere I see angle 6, I can replace it with angle 1. And that's a big deal here, because here's angle 6. I want 1 plus 7 to be 180. I have 6 plus 7 equals 180. So how do I make it so that it's a 1 instead of a 6? Well, I can take the 6 out and replace it with a 1. What do you call that when you take something out and replace it with something of equal value? That is called a substitution. I'm going to put sub S for substitution. And now we're done. That's that entire proof. All right, I'm going to do the next one. So here's the next proof. They tell us that A and B are parallel. I love highlighting parallel lines so I don't forget which ones are parallel. You will have access to colored pencils on tests and quizzes. So A and B are parallel. Angle 3 and angle 7 are congruent. So 3 and 7 are congruent. And we're trying to prove that 1 and 11 are congruent. Well, let's look at 1 and 11. Here's 1, here's 11. Are there any parallel lines involved with angles 1 and 11? The answer is no. We've got to get good at this. If all of this was gone, Do you have any parallel lines left? No. 1 and 11 have nothing to do with parallel lines. So please, please don't go straight from 1 to 11. You can't do it. You can't do it. The brown lines are parallel. That means we can go this way and we can go this way. That's it. We can go up and down. The top and the bottom are parallel. That means we can move up and down. And when you circle the angles, you better be crossing 2 parallel lines. 2 parallel lines. So let's see what we need to do. We need to connect 1 with 11. We got to go from 1 all the way to 11. But we can't go this way because there's no parallel lines that go that way. So that won't help us. But they told us 3 and 7 are connected. So you got a game plan. You got to make use of what they give you. They're not telling you 3 and 7 are congruent for giggles. We're trying to get 1 to 11. They gave us 3 and 7. We're trying to find relationships between 1, 3, 7, and 11. So let's start at angle 1. Does angle 1 have a relationship with 3, 7, or 11? And the answer is 3. Not 7, not 11, but 3. What's the deal between 1 and 3? What's going on there? Well, those are parallel lines. They're on the same side, 1 in, 1 out. Those are corresponding angles. So I'm going to make my T-chart for statements and reasons. Statements, reasons. The first statement is just the given information. A is parallel to B. Angle 3 is congruent to angle 7. And that was just given to us. And we just said that angle 1 is congruent to angle 3. And we knew that because they are corresponding angles. That's the corresponding angle theorem. But again, corresponding by itself doesn't mean anything. Like angle 3 and 5 are corresponding. Would we say they're congruent? Nope. No, we wouldn't. 3 and 5 are corresponding, but they don't use parallel lines. What's the very beginning of the corresponding angle theorem? It's if lines are parallel. That's the whole premise. If the lines aren't parallel, then it's meaningless. We can't do anything with it. But 1 and 3 are congruent because they do use parallel lines. A and B are parallel. 3 is on A, 1 is on B. All right. So we have congruent corresponding angles. So we have 1 is congruent to 3, right? We just said that. They told us 3 is congruent to 7. So what does that mean? Let's think about that. Well, if I said angle 1 was 50 degrees, just making that up, I don't know how big it is. I don't care how big it is. But if that was 50 degrees, wouldn't angle 3 also be 50 degrees? Those are corresponding angles. So they'd have to be equal, right? So if 1 is 50 degrees, then 3 is 50 degrees. And if 3 is 50 degrees, what do we know about 7? It's the same size as 3. It's also 50. So we would know that 1 and 7 are the same. But I don't want 1 and 7 to be the same. I want 1 and 11 to be the same. Okay. So how do we do that? Right now we have 1 goes to 3, 3 goes to 7. We need to finish the job. We need to make it to 11. Can we do it? Let's try. What kind of angles do we have over here? 7 and 11. Well, if you're not sure, there's a few ways to do it. But one way I told you guys is trace the angles. Like if I'm looking at angle 7, start on one of the parallel lines, turn on the transversal, turn on the parallel line. I drew angle 7, I drew angle 11. Those are the inside corners of the letter Z. When you have the inside corners of a letter Z, they're alternate interior angles. And are the lines parallel? Yes. So if lines are parallel, alternate interior angles must be equal or congruent in this case. So we know that angle 7 is congruent to angle 11. How do we know that? They are alternate interior angles. Now, just being alternate interior is not enough. Like we talked about, the lines have to be parallel. But that's called the alternate interior angle theorem. Okay, so this year I told you guys in class, but if you weren't here, we're going to take some shortcuts a little bit. This is technically something called transitive, right? There's something called transitive, and there's something called substitution. Transitive, in a way, substitution, is a form of substitution. You can kind of think about it like that. It takes a little bit for students to really understand the difference between these two, and we just don't have the class time to go over that this year. So for what we're doing, we're going to just always call them substitutions. But on my answer keys and other videos that I've made, if you see me calling it transitive, just know that it's a form of substitution. It's a bit deeper than that, but we're not going to mess with it too much. It's called the transitive effect. It's like a cause and effect situation. Basically, the idea is that angle 1 leads to 3, 3 leads to 7, 7 leads to 11, right? So 1 leads to 3, 3 leads to 7, 7 leads to 11. So what does 1 do? It eventually leads to 11. That is the transitive effect. But we're not going to mess with that. We're not going to go over that. We're not going to use that. Unfortunately, it's just one of those things that is not worth the time investment that it takes. So we're going to call it substitution, but we're at a point now where we can say angle 1 is congruent to angle 11, and we're going to call it substitution. All right, and that's it. That's all they ask us to prove. All right, I'm going to do 2 more proofs in this video, and I think the next 2 are harder than the first 2. Something I want to take a look at is they're trying to prove C and D are parallel. We don't know that they're parallel. They didn't say they are parallel. They said prove they're parallel. So, like, this is confusing, I know. But if I have a couple of lines here, and I tell you that they are parallel, right? And this is like angle 1 and 2. If you know they're parallel, then you would know that angle 1 is congruent to angle 2, and it would be the alternate exterior angle theorem. It's because you knew they were parallel, therefore they're equal, right? That's the way we've done it. That's the only thing we've done so far. But what if we flip the script? What if I didn't tell you they're parallel? What if I said 1 and 2 are equal? If you know that 1 and 2 are equal, if you know that alternate exterior angles are equal, then that means that the lines are parallel. So it does work both ways. If any of these 5 things happen, then they all happen. What do I mean by that? If same side interior angles add up to 180, then you know the lines are parallel. If alternate interior angles are equal, then you know the lines are parallel. If any of these 5 things happen, then you know that the lines are parallel, therefore they all happen. It's called the converse of the theorem. So when you flip the script and go the other way, that's called the converse. So if you know the lines are parallel, therefore this stuff is true, that's the normal way. If you know that this stuff is true, therefore the lines are parallel, that's called the converse. We'll talk about it more as we go. But that's what's going to happen here. If I'm proving lines are parallel, I know I'm going to use the converse at some point. So what do we have? We have a given statement. I'm going to make my T-chart. Statements and reasons. And I'm going to go ahead. Guys, I can't be bothered. I can't rewrite the given every time. You can do this as well. I'm going to put little squigglies there. And that just represents all of this. All of this is here. Some of these givens get pretty long. I'm not going to write them all. I'm just not going to do it. So that's my given. It's like I wrote it, but I just didn't want to. I'm going to go ahead and mark line A and B. We're told that they are parallel. So A and B are parallel, and they tell us that angles 2 and 3 are equal. Okay. So forget the prove line, forget anything but this picture here. We have parallel lines. What do we know because of those parallel lines? And a lot of people really mess this up. Could I say right now that angle 1 is congruent to angle 2? Could I say that? 1 and 2, are they congruent? They're corresponding angles. Well, the answer is no. We can't say that. Guys, if I erased all of this, if that wasn't there, we still have 1 and 2. Do 1 and 2 use parallel lines? And the answer is no. There are no parallel lines in that picture. I cannot say 1 and 2 are congruent. I don't know that yet. I don't know that yet. It doesn't say C is parallel to D. It's saying prove it. So we can't pretend like it's true. the only properties we can use are going between the parallel lines. I can connect 1 to 3. I have properties with 1 and 3. 1 and 3 make the letter Z. 2 and 4 make the letter C. If you remember the letter Z, the inside corners are alternate interior angles. The letter C, the inside corners are same side interior angles. That's the stuff I can do. I cannot go this way. I cannot do 3 and 4. I cannot do 1 and 2. I can't do it. When I circle the angles that I'm working with, I better touch 2 parallel lines. When I circle, if I go 1 to 2 and I circle them, I don't touch any parallel lines. So I've got to use parallel lines. So I am going to use angle 1 and 3. So I do know that angle 1 is congruent to angle 3. I know that. How do I know that? What kind of angles are those? Start on a parallel line, turn. They're the inside corners, right? They're alternating and they're interior. So you do need to know how to name the angles. That's another video if you need to go watch it. But it's the alternate interior angle theorem. Okay. So I know 1's congruent to 3. They told me 2's congruent to 3. So if 1 is the same as 3, let's pretend it's 50. If 1 is 50, isn't 3 50? And if 3 is 50, isn't 2 50? So what do you know about angles 1, 2, and 3? All of them. They got to all be the same size. So can I now say that angle 1 is congruent to angle 2? But Mr. Van, you said you couldn't say that. I know. I said it earlier. Didn't we just say how we can't talk about 1 and 2 being equal? The reason is we didn't know it at the time. You couldn't say it earlier because you were pretending they're corresponding angles. We don't know they're equal because they're corresponding angles. That's not how we know. We know they're equal because we know 1 and 3 are equal because they're alternate interior. We know that 2 and 3 are equal because we were told that. So if 2 is equal to 3 and 1 is equal to 3, then 1 and 2 have to be equal. And that reason is substitution, has nothing to do with parallel lines. But if these two angles are equal, if corresponding angles are equal, remember, if we go backwards, if corresponding angles are equal, then lines are parallel. It works backwards. So can we now say C is parallel to D? Yes. We have corresponding angles. They are equal. Therefore, the lines must be parallel, and that is the converse of the corresponding angle theorem. You got to get that word converse in there. If you're proving lines are parallel, you better have the word converse in there. Whew, that's a tough one. All right, we're going to do one more real quick. I need to make sure we understand this process here. So first off, like if I'm looking at this, I use numbers. You're allowed to do this too. So like this small angle, I'm gonna call it 1. This is 2. I'm gonna call the whole thing 3. It just so many letters, so much writing. It's so easy to mess up, especially like if you have dyslexia. Like getting all these letters in the right order and writing them, and it just takes so much time. I don't like it. So I number my angles. As long as you clearly label which angles are which, I'm okay with you doing that too. All right, so let's make our chart. What are the things that we know? We know the given. I'm not going to write all that. But real quick, I'm going to rename them. So this is angle 3, this is angle 1, and this is angle 2. Okay. So if I told you angle 3 is a right angle, which I did, angle 3 is a right angle, what do we know about that angle? We would know that the measure of angle 3 equals 90 degrees. How do we know that? That is just the definition of right angles. And I like to use symbols, but if I told you something's a right angle, you would know it's 90. And the reason you know that is because you know the definition of right angle. So that's our claim, and that's how we know it. Okay. So we've explained this. Now we have to explain the picture, and this is where a lot of people really mess up. Don't tell me angle 1 plus 2 equals 90. Just tell me what you see right here. Forget the whole right angle bit. The only thing we can say from this picture that well, there's some things we can say, but the main thing that matters is that angle 1 and angle 2 add up to angle 3. That's what we're going to write in here, that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3. When you write these proofs, you need to explain the given statement. You need to explain the given picture. Do not make connections until you've explained them individually. Now that we've explained them individually, now we can connect them. What is that reason? That's called the angle addition postulate. Right? Angle plus angle equals bigger angle. That's the angle addition postulate. Now, look at this. 3 and 90, they're the same thing. So that means anywhere I see angle 3, what can I replace it with? I can replace it with 90. So the measure of angle 1 plus the measure of angle 2 equals 90. Now I can say that thing you've been wanting to say since the beginning. That's a substitution. I took out 3 and replaced it with 90. That is a substitution. Now I can say that angle 1 and angle 2 are complementary angles. What is that reason? That's just the definition of complementary, right? If I know 2 angles add up to 90, that's what complementary means. All right. So we just did like 4 proofs. We're going to do some more later, but that's just an intro. Hopefully that was helpful, my friends.